In this session, we will examine the chain used in construction rigging. We will cover safe working load, characteristics, inspection, care and use. In the past, chains were not widely used in construction. Made from low-carbon steel for many years, chain had relatively low strength. Chains had to be heavy and cumbersome to provide sufficient capacity. Low-carbon chains also had a tendency to work harden with use. Brittleness led to sudden failure without warning. Today, however, all chain used for overhead lifting must be grade 8 heat-treated alloy steel and embossed with the letter T or the number 8 at regular intervals. High strength and ductility combine to make such chain extremely tough. In addition to embossed identification, chain slings should have a tag attached to the master link showing serial number, size, material, reach, and safe working load. If the tag is missing or illegible, chain slings should be taken out of service and returned to the manufacturer. Most chain manufacturers and suppliers provide inspection and repair services for their customers. This development, along with improved materials and quality control, has made chain more popular in construction rigging. All chain manufacturers publish safe working loads for the various sizes of chain they produce. The specification should be consulted before using a chain for hoisting. Pay particular attention to the factor of safety quoted. Some manufacturers rate their chain for a factor of safety of 3.5 or 4. If this is the case, multiply the factor of safety by the safe working load quoted and divide by 5. This will give you the safe working load based on a factor of safety of 5. When ordering new chain slings for construction, request that the safe working load on the tag be based on a factor of safety of 5. Make appropriate reductions to the safe working load if the sling is choked, used on an angle, worn, or subjected to shock loads. Alloy steel chain can be used in temperatures up to 500 degrees Fahrenheit without reducing the safe working load. But above this level, the load limit decreases. Further information on the effect of high temperatures is available from the chain manufacturer or supplier. Chains withstand rough handling, do not knot, are easily stored, have dead flexibility, and when used as slings, grip the load well. They are much more resistant to abrasion and corrosion than wire rope, and are particularly well suited as slings for lifting rough loads such as heavy concrete castings. Careful control is required to ensure that only alloy steel chains are used on site. The binder chain, normally found on delivery trucks, for instance, must never be confused with the alloy steel chain required for hoisting. Chain removed from chain hoists should be cut up into small pieces and discarded. Regular alloy steel chain will stretch by 15% before breaking, but the chain used in chain hoists is case-hardened and will stretch by only 3%. Such chain is too brittle for any application other than chain hoists. Hardware used with chain must be forged alloy steel and designed for the particular size of chain being used. Manufacturers will help you in selecting the right hardware. There are 2 levels of inspection for chain used regularly in hoisting operations. The first involves a visual check by the rigger before each lift. At this point, the chain is checked for noticeable wear or damage. The second level of inspection is a detailed link-by-link examination by a competent inspector. This detailed inspection should be performed at least once a month if the chains are used regularly. It's a good idea to set up an inspection schedule and keep a logbook on each chain. Manufacturers will supply cards so that the characteristics and conditions of each chain can be recorded during the monthly inspection. Before new slings are put in service, carefully measure the reach of the chain from the bearing point on the master link to the saddle of the hook and record it on the card. This information will be useful during subsequent inspections when checking for stretch. Whenever a chain is subjected to shock or impact loads, it must be immediately inspected before going back into service. When inspecting chain, remember to give every link a close examination. One bad link is all it takes to fail. Next, we're going to cover some guidelines for periodic inspection. Clean the chain thoroughly in a solvent solution. Lay it out on a clean surface or hang it up in a well-lit area. Use a magnifying glass when necessary. Look for elongated or stretched links. When the links are severely stretched, they tend to close up, so that in some cases, stretch may be indicated by links that bind or a chain that won't hang perfectly straight. Measure the reach of the chain and compare it with the initial value on the card. If inspection reveals any stretching, take the chain out of service. Look for bent, twisted, or damaged links that often occur when a chain sling has been used on a load with sharp, unprotected edges. Look for cracked links. Any crack, regardless of size, means the chain is unsafe and must be removed from service. Where a crack is suspected, soak the link in thin oil and wipe it dry. Dust the surface with powdered chalk or other white material and let it sit for several hours. Oil trapped in any crack will be drawn out and discolor the white coating. Look for gouges, chips, scores, or cuts in each link. If damage is deep enough to reduce link size below wear limits specified by the manufacturer, the chain is unsafe. Watch all sharp nicks and cuts because cracks usually begin at or near them. All nicks and gouges should be ground out and the new diameter measured for allowable wear. Check for wear between links and on the outside of link barrels. Manufacturers publish tables of allowable wear for various link sizes. Many companies also supply wear gauges to indicate when a sling must be retired or links replaced. Gauges or tables from a particular manufacturer should only be used on that brand of chain, since the exact dimensions of a given nominal size can vary from one manufacturer to another. Check for weld spatter or damage caused by torches or arc welders. Such damage may destroy heat treatment entirely. Look for severe corrosion resulting in lost metal or severe pitting. Inspect chains regularly. Take defective chains out of service right away. Damaged or worn sections can sometimes be returned to the manufacturer for repair and reconditioning. Only specialists can repair alloy steel chain. Don't try it yourself. Now that we've seen the damage that can occur, let's look at how to prevent it. Use only alloy steel chain. Never exceed rated safe working loads. Know the weight of all loads to avoid accidental overload. Store chains where they will not be damaged or corroded. Never shorten a chain by twisting or knotting it or by using nuts and bolts. When required, use a shortener recommended by the manufacturer. When wrapping chain around sharp edges, use pads or softeners to prevent damage to the links. Never use homemade links or makeshift fasteners formed from bolts, rods, or wire. Never hammer a chain to straighten the links or to force the links into position. Avoid crossing, twisting, kinking, or knotting a chain. Never use the tip of chain hooks to carry a load. Never re-weld alloy steel chain links. They must be replaced by the manufacturer. Make sure all attachments and fittings are of a type, grade, and size suitable for service with the chain used. Make sure that alloy steel chains are never annealed or heat-treated. If alloy steel chains are annealed, their capacity will be completely destroyed. Remember, use only grade 8 or grade T alloy steel chain embossed with identifying marks. Do not load a chain beyond its safe working load. Avoid shock loads. Chains should be inspected regularly, link by link. Keep records on each chain identifying its characteristics, condition, and inspection dates. Chains that have been stretched by overloading should be taken out of service and destroyed. By now, you should be able to identify, inspect, and maintain alloy steel chain. In addition, you should be familiar with its chief characteristics and typical applications. Further information is available from your Construction Safety Association of Ontario.